Hello friends, in this video we are going to talk about the evaluation of performance of boiler. The performance of boiler is calculated for comparing the boilers for its evaporating capacity, energy consumption and heat balance sheet. The quantity of the heat supplied to vaporize water from and at 100 degrees centigrade and 1 atmosphere is referred as evaporation unit. Now let's talk about the evaporative capacity of the boiler. The quantity of steam generated by a boiler at full load is called the evaporative capacity of the boiler. I repeat again, quantity of the steam generated by the boiler at full load is called the evaporative capacity of the boiler. The performance of the boiler is often measured in terms of evaporative capacity, and the evaporative capacity of the boiler may be expressed in various ways. It may be expressed on the basis of time, it may be expressed on the basis of the heating area, or it may be expressed on the basis of the fuel burnt. So the evaporation rate can be given as kg of steam per hour, which is nothing but the ratio of mass of steam generated to the time period in hours. It can be given as the kg of steam per meter square of heating surface, which is nothing but the ratio of mass of steam generated per hour to the heating area of the grate in meter square, or it can also be given as kg of steam per kg of fuel fired, which is the ratio of mass of steam generated per hour to the mass of fuel burned per hour. Now let us talk about the equivalent evaporation. Friends, the quantity of the steam generated by a boiler depends on four different parameters such as feed water temperature, working pressure, fuel used and the quality of the steam generated. In practical situation, the different boilers use feed water at different temperatures, they operate at different pressures and they generate different qualities of steam. Therefore, such boilers cannot be compared unless some standard parameters are adopted. And the standard condition adopted is the temperature of feed water at 100 degrees centigrade and converted into dry and saturated steam at 100 degrees centigrade. And as per these standard condition, 1 kg of water at 100 degrees centigrade necessitates 2257 kilojoule to get converted to steam at 100 degree centigrade. In other words, I can say that the feed water is taken at 100 degrees centigrade and working pressure is at 1.01325 bar, and at this state the water evaporates at 100 degrees centigrade and requires 2257 kilojoule per kg of latent heat to convert it into steam at 100 degrees centigrade. So the evaporation rate is defined as the amount of dry and saturated steam generated from feed water at 100 degrees centigrade at normal atmospheric pressure. So in short, we can define it as the amount of steam generated from and at 100 degree centigrade. Now let us consider a boiler is generating say MA kg of steam per hour at a pressure of P and temperature T. Now let's say that H is the enthalpy of steam per kg under the generating conditions, and this H is equal to HF plus HFG for dry saturated steam at pressure P. It is equal to HF plus X into HFG for wet steam with dryness fraction X at pressure P. It is equal to HF plus HFG plus Cp into T sup minus Ts for superheated steam at pressure P and temperature T superheated, and HF1 is equal to specific enthalpy of water at a given feed temperature. Then the heat gained by the steam from the boiler per unit time is equal to Ma into H minus HF1. The equivalent evaporation Me from the definition of equivalent evaporation is obtained as Me equal to Ma into H minus HF1 divided by HFG, which is also equal to Ma into H minus HF1 divided by 2257. So this is the equivalent evaporation Me, which is equal to Ma into H minus HF1 divided by 2257. The evaporation rate of boiler is also sometimes given in terms of kg of steam per kg of fuel, and the presently accepted standard of expressing the capacity of boiler is in terms of the total heat added per hour. Now let us look at another important parameter to find out the performance of the boiler, which is nothing but factor of evaporation. So let's see what is factor of evaporation. Factor of evaporation is defined as the ratio of heat received by 1 kg of water which is working under working conditions to that received by 1 kg of water evaporated from and at 100 degrees centigrade. Okay, I repeat again. The factor of evaporation is defined as the ratio of heat received by 1 kg of water under working conditions to that heat received by 1 kg of water evaporated from and at 100 degree centigrade. So this factor of evaporation is denoted by Fe, and this factor of evaporation Fe is given as H minus HF1 divided by 2257. This factor of evaporation Fe can also be expressed as the ratio of Me and Ma, where Me is the equivalent evaporation from and at 100 degrees centigrade and Ma is the evaporation per kg of fuel. Now friends, let us talk about another important parameter for finding the performance of the boiler, which is nothing but boiler efficiency. So let's talk about boiler efficiency. Boiler efficiency is the ratio of heat actually utilized in generation of steam to the heat supplied by the fuel in the same period. So it is the ratio of, as I said, heat which is actually utilized in the generation of steam to the heat supplied by the fuel in the same period. It is the ratio of Ma into H minus HF1 divided by C, where Ma is the mass of water actually evaporated into steam per kg of fuel at the working pressure, and the C is the calorific value of the fuel in kilojoule per kg. So if this boiler if the boiler, economizer and the superheater, they are considered as a single unit, the boiler efficiency is also termed as the overall efficiency of the boiler. Okay. So when economizer, superheater and boiler, all these components are considered as a single unit, then the boiler efficiency can also be called as overall efficiency, and this overall efficiency of the boiler, it is the ratio of heat utilized in the boiler to the heat produced by burning of the fuel. Now there are certain important parameters, certain important factors on which this boiler efficiency depends, and these factors are categorized into two parts as fixed factors and variable factors. So let's see what is this fixed factor and what are these variable factors. Now fixed factors are boiler design, heat recovery equipment, built-in losses, rate of firing, properties of the fuel burnt. Okay. So this boiler design, it includes the arrangement and effectiveness of heating surfaces, and the shape and volume of the furnace, the arrangement of flues, the arrangement of steam and water circulation. Then the heat recovery equipment includes the economizer, superheater, air preheater and feed water heater. Then built-in losses includes the heat transfer properties of the settings and construction materials, flue gas and ash heat losses. Then rated rate of firing, the furnace volume and heating surface, and properties and characteristics of the fuel bin. So all these factors are called as fixed factors. Now let's see what are variable factors. Variable factors are given over here. Variable factors are actual firing rate, fuel condition as it is fired, the condition of heat absorbing surfaces, excess air fluctuations, incomplete combustion and combustibles in the refuse, change in the draught from the rated due to atmospheric conditions, humidity and temperature of the combustion air. Okay. The next important parameter for evaluating the boiler efficiency is the different heat losses that are taking place. Okay. This also affects the boiler efficiency. Now let's see what are the different heat losses in a boiler plant. Okay. Now there are different heat losses that occur in the boiler plant, such as heat loss due to flue gases, heat loss due to incomplete combustion, heat loss due to unburnt fuel, and the heat losses due to convection and radiation. Okay, so let's look at all these losses one by one. Heat loss due to flue gases. The flue gases contains dry products of combustion as well as the steam generated due to combustion of hydrogen in the fuel. So the heat loss through the dry flue gases is given as Qg, and Qg is equal to mg into Cpg into Tg minus Ta, where mg is equal to mass of gases formed per kg of coal, Cpg is the specific heat of gases, Tg is the temperature of the gases, and Ta is the temperature of air entering the combustion chamber. So heat carried away by the steam in flue gases is given as Qs, and Qs is equal to Ms1 into Hs1 minus Hf1, where Ms1 is the mass of steam formed per kg of fuel due to the combustion of H2 in the flue. Hf1 is the enthalpy of the water at boiler house temperature and Hs1 is the enthalpy of steam at the gas temperature and at a partial pressure of steam vapor in the gas. So this heat loss through the flue gases can be reduced by passing the flue gases through the economizer and air preheater. Now let's look at another type of the heat loss. So it is heat loss due to incomplete combustion. Friends, the combustion is said to be incomplete if the carbon burns to CO instead of CO2. That means if the carbon is burning to carbon monoxide instead of carbon dioxide, then it will be called as an incomplete combustion. So 1 kg of carbon releases 10120 kilojoule of heat if it burns to carbon monoxide, whereas it can release 33800 kilojoule per kg if it burns to carbon dioxide, that is CO2. So the heat loss due to incomplete combustion of 1 kg of carbon is given as the difference between these two, that is 33800 minus 10120, which is equal to 23680 kilojoule. So heat loss due to incomplete combustion of 1 kg of carbon is 23680 kilojoule. Okay. Now if CO is present in the flue gases, carbon monoxide is present in the flue gas, it indicates that the combustion of the fuel is incomplete. If the percentage of carbon monoxide and carbon dioxide in flue gases by volume are known, then carbon burnt to CO instead of CO2 per kg of fuel is given by the mass of carbon burnt to CO equal to CO into C divided by CO2 plus CO. Okay, where the CO and CO2 are expressed in percentage by volume in the flue gases, and C is the fraction of carbon in 1 kg of the fuel. Now the heat loss due to incomplete combustion of carbon per kg of fuel is given as CO into C divided by CO2 plus CO multiplied by 23680 kilojoule per kg of fuel. Okay. So this loss due to incomplete combustion, okay, it can be reduced by supplying excess quantity of air and giving a turbulent motion to the air before it enters the furnace in order to help the mixing process. Okay. The next type of the heat loss is due to the unburnt fuel. So if MF1 is the mass of the unburnt fuel per kg of fuel used and C is the calorific value of the fuel, then the heat loss due to unburnt fuel is given as Q equal to MF1 into C. So in case of solid fuels, this loss cannot be completely avoided. The next type of the heat loss taking place is due to convection and radiation. So as the hot surfaces of the boiler are exposed to the atmosphere, the heat loss to atmosphere by there is a heat loss to the atmosphere by convection and radiation process, and the loss of heat due to convection and radiation losses is given as the heat released per kg of the fuel minus the total heat of the losses in the all the above three cases, that is the heat loss due to flue gases, the heat loss due to incomplete combustion, and the heat loss due to unburnt fuel. So these losses can be reduced by providing proper heat insulation on the boiler surface. Okay. So this was all about the parameters which are responsible for finding the performance, of the boiler. Thank you.